Compound inequalities. When we're looking at compound inequalities, we're going to take what we did with linear inequalities and we're just going to build upon that concept. When you're looking at a compound inequality, we can take two approaches. This is two linears being put together. So I could take this situation and say, well, let's do 3 is less than or equal to 2x plus 2. And then let's do 2x plus 2 and make it less than 6. And then I could approach it like I did with linear ones and say, okay, well, let me say minus 2 on both sides. So it gives me 1 is less than or equal to 2x and then divide by 2. I did not multiply or divide by a negative, so that would be my final answer. Now, let's do the other inequality we've created. So I'm going to say minus 2. That gives me 2x is less than 4 and then divide. So x is less than 2. So I was able to take a compound, which was just two simple inequalities, and then put them together. So that means x-wise, I could say x has to be greater than 1/2, but less than 2. Now with these inequalities, we could take this all in one approach. And so what I'm going to do is let's just work this again and see what goes on. Say I want to take 3 is less than or equal to 2x plus 2 less than 6. What I could do is I could create barriers right here. And I could say, you know what? My goal is to get x by itself. So in order to get x by itself, I just need to remove both of those 2's. So in order to remove 2, I would subtract 2. When we take it in this all-in approach, I'm going to do it small steps at a time. So if I know I need to subtract 2 in the middle, I'm going to also subtract 2 from the other two sides. So it gives me 1. I did not multiply or divide by a negative, so I'm going to keep my signs the same. 2x, this 2 would cancel, less than 4. Last step, again, our goal is always to get this x by itself. So in order to get x by itself, I'm going to divide everything by 2. So it gives me 1/2. I did not multiply or divide by a negative number. I did divide, but it went negative. Less than or equal to x less than 2. So you can see I was able to get the end result that I did earlier when I split it up. Now let's take this further. Let me show you what this number line would look like. Here's 1/2. Here's 2. I'm equal at 1/2. I'm not equal at 2. And I want all these numbers in between. So when we're working with compound inequalities, this is another way that you could approach it and do it all in one swoop. The next type of an inequality I want to deal with is an absolute value inequality. Absolute values are unique, and the fact of absolute value is telling you the distance from 0. So when we move it into inequalities, I'm looking at all the numbers that are going to have some kind of distance from where I'm going. So let's do a recall right here. Recall that with absolute values, it is doing the distance from 0. And distance is always positive. So if I have x minus 1 and that's equal to 3, and I want to solve that out in an equation sense, I would say, well, then x minus 1 could equal 3, or x minus 1 could equal negative 3. And then I could solve both of those individual ones out. So I get x to be 4. I could add 1 to both sides here, and that gives me x to be negative 2. So in the case of solving a simple equation of absolute value, I get 2 values. Well, so what we need to do is now take this as an inequality, and we're going to set up a double inequality. So it really does go into a double round like it did with solving. So you're going to take x minus 1, and we're going to say, well, it could be less than or equal to 3, or it could be more than negative 3. Again, that's coming from this area over here with the positive 3 and the negative 3. And so then we go back into solving. This is why it comes after a compound inequality. Here's my inequalities. Again, my goal is to get this x by itself. And so in order to get this x by itself, I'm going to have to add 1, and I'm going to add 1 to all 3 sides. So it gives me negative 2. 3 plus 1 gives me 4. In the middle, it cancels, which was my goal. I did not multiply or divide anything by a negative, so I'm going to maintain my inequalities. So my final answer would be negative 2 is less than or equal to x is less than or equal to 4. If I wanted to write that in interval notation, that would be -2 to 4, and I would include brackets on both of those because I have an equal sign.